Hello friends, and welcome to downtown Boise, Idaho. We are a long way from the typical field settings where we shoot these videos. So a little bit of background here on why I'm in downtown Boise. I had plans to come to this area and do some videos out in the field, but as I left Twin Falls, it became really foggy. And it's still pretty foggy, but I thought I would try something a little different. I hope you find it entertaining and educational at the same time. A few years ago, I wrote a book called Geology Underfoot in Southern Idaho, and each chapter in this book is a different location, and what you find there gives you directions on what to see, what to look for. Some of these places I've done videos on, others of them I haven't, but one of the most unique chapters in the book was this one here on the urban geology in Boise. And so what I think we're going to do with this video is I'm going to take you on a little tour of several different buildings that are made out of this beautiful stone that we see in different places. So we're going to look at the building stone on several buildings in downtown Boise and see what we can learn from it. What might be fun here is that I have a lot of viewers and subscribers that are from other parts of the country and the world, and who knows, we might just see some rocks or some stone, I suppose, that is from your region, and so you might recognize some of the rock here in downtown Boise. And so, as you know, rock and stone are a little bit different. Typically, if you know, we think of rocks in geologic context often as the things we see out in the landscape, the things we study. So what does the word stone mean? And so typically stone is a rock put to some use. So in this case, this would be rock that's quarried and then has some commercial value to it. And what we're going to see is that the names that we use in geology to describe rocks are quite different than those in the stone industry. And so as I did research for this chapter 6 or 7 years ago, it was a lot of work. It was probably the most difficult chapter to put together because the names that the stone industry uses are very different than what we would call those same materials as geologists. So what they called a marble maybe wasn't even a marble, or what they call a granite might be a little bit different. And so it became quite challenging, but I learned a lot, and I thought it might be fun to share this in video form. If you're interested in the book, it's on Amazon, it's in other places as well. If you want a signed copy, you can contact me, or I'll put a link in the description to some information about it. But let's go ahead and start with our first building stone of interest here. So we're at the Wells Fargo Center. This was a building that was built in 1988. And we've got two different types of intrusive igneous rock here. We have on the left there kind of a lighter colored granitic rock, and on the right a little bit darker rock. Again, in the stone industry, these are all called granites. The one on the right is called carnelian granite, and the one over here is called let's see, sunset red granite. So these are the stone industry names, but let's focus on this one here because I think it presents a nice contrast to another stone we're going to look at here just across the plaza here near the Wells Fargo Center. And so this rock was actually quarried out of the ground in Texas near a town called Marble Falls. It's about 1.5 billion years old. It's formerly called the Town Mountain granite. And what we can see here is we've got some really spectacularly large potassium feldspar crystals. We've got a nice big one here, another big one here. We can see their overall rectangular shape. And because so many of these feldspars, there's a lot of them in here, but we can see a lot of these rectangular shapes showing off those two cleavage planes and their 90-degree intersection. Because the feldspars are so well formed, again, we sometimes call those crystals euhedral, we can infer that they formed first. In fact, Bowen's reaction series tells us that they formed before some of the other minerals we might see here. So these crystals formed early as the magma was cooling and crystallizing, and then later, as the cooling and crystallization continued, some of these other minerals would have formed. And so we've got some quartz in here forming these kind of grayish minerals in here, a little bit of plagioclase, that's the white, and then we have some of these bigger darker colored minerals. I believe some of these are biotites, some of these little specks in here, and some of these larger ones might be amphibole. So a really nice little rock here, right on the building of the Wells Fargo Center. That's a good, I don't know how many stories this is, but it's definitely a tall building here. Mainly, again, this light colored granitic material accented by the trim, this darker carnelian granite. But let's now take you over to the Wells Fargo, or excuse me, the CenturyLink Arena over across the way here to the Boise Center, and we'll look at something that's quite a bit different. Okay, so I just walked maybe 100 yards or so across the Grove Plaza to what's now Idaho Central Arena, formerly CenturyLink Arena. And this building is faced by a really interesting type of stone. Let me set my thing down here so I can look at it a little closer and give you guys a nice view. So as you look at this rock, it's kind of an odd looking rock. It looks somewhat similar to what we've seen before in terms of the minerals we see. We see the pink color that we know is part of K-spar. We can see some kind of grayish material here. But what's odd about this rock are these rounded shapes here. Just kind of an odd looking material overall. This is actually a granite, believe it or not. This is called rapakivi granite, and that's the geologic name. In the stone industry, this is known as Baltic brown. But what's odd about this and what makes this kind of special is that it has these, again, kind of rounded or orb or elliptical shapes of crystals. Contrast that to what we just looked at, where we saw those nice characteristically rectangular or square shapes in the potassium feldspar. And so these are a little bit different. Some of these actually are rimmed by some gray material here. This is actually a type of plagioclase feldspar, calcium-rich plagioclase. And so it's kind of odd, and this type of rock is actually kind of baffled geologists for probably close to 100 years. There's a lot of different models and ideas about how this might have formed, but as far as I know, there's no consensus on exactly how this material, this type of rock, forms. This particular rapakivi granite is from Finland. It's about 1.6 billion years old, but we find similar rocks to this on all the continents in a few locations. So it's not a common type of granite, but it's common enough that you can find it in different places. And so just kind of giving you a good look at this, again, these pink potassium feldspar crystals, and in places they're rimmed by plagioclase feldspar. Some of the rounded crystals lack the rims, but just a really odd rock, really interesting. So this is, again, the Idaho Central Arena, kind of an event center, and some of the stone that they use to face it. You can see sort of the thickness of the stone right here. So interesting rock, but we'll go on to our next one. Next, we're gonna head up to the Idaho State Capitol, which has a lot of different rocks of various types, and we'll kind of uncover some mysteries there. Okay, next building on our list is the Idaho State Capitol building. Really an impressive structure. I believe it was constructed from 1905 to 1920. Most of the building is this kind of brown stone, which is table rock sandstone. I'll do a separate video on table rock up at the quarry, because it's a cool enough rock and a cool enough story that it deserves its own treatment. So you can see this nice brown sandstone here, and then we have the trim features, the steps, the big kind of spherical orbs up here. These are granites, and these are from Butte, Montana. This granite's about 76 million years old, so it's Cretaceous in age. Part of I think it's the boulder batholith near Butte, Montana. And so just a nice view, kind of a typical granite, equal size crystals, all the usual suspects in there. Just sort of a textbook granite, not seeing any inclusions or xenoliths or anything in here, but still pretty attractive. So let's head inside the Capitol, and that's where the real cool geologic story lies. Okay, welcome to the inside of the Idaho State Capitol building. Beautiful building. We're in the Rotunda, I believe that's what this is called here. And you can see just, they've got some of the decorations up for Christmas, but we can see some of the beautiful stone that they've used in here. And when you come to the Capitol and come on a tour, or if you read information about it, they talk about some of the different stone that they've used here. I'm gonna get down on my hands and knees and show you this a little bit up close here. And what I found in doing research for my book is that some of the information is wrong, to put it bluntly. And so not only wrong in terms of rock type, which we can kind of forgive because we know the stone industry uses different terms for their rocks. They tend to use, look at texture and durability of the rock to describe it. That's why there's so many types of granite out there, as opposed to geologists where we're looking at mineral composition, how the minerals are arranged, that sort of thing. But let's spend some time looking at these rocks closely. And so let's start with this red one. This red rock is kind of interesting. It has a really kind of interesting texture. You can see these kind of white blobs, kind of ghost looking shapes. Some of them are kind of a little bit transparent or maybe almost translucent. You can kind of see into them a little bit. The state capitol information says that this is from Georgia. And when I was doing research for the book, this was probably the hardest and trickiest one to pin down, because it turns out it's not from the state of Georgia. It's not even from the Republic of Georgia over in Eastern Europe. Where this is actually from is a town in Vermont called Georgia. So Georgia, Vermont is where this rock comes from. It's actually not even a marble, as the state capitol information on the website would lead you to believe. This is actually, and we can tell it's not a marble because marble, remember, is recrystallized calcite. It's a metamorphosed limestone, and you can see the shapes in here just really don't lend themselves to the type of thing we would see in a typical marble where we'd have recrystallized calcite. So this is actually a dolostone, kind of like a limestone. It's a sedimentary rock, but instead of being calcium carbonate, some of the calcium has been replaced with magnesium, so it's a little bit different than that. This is from the Cambrian. It's about 520 million years ago. It's actually called the Dunham Dolostone is the formal stratigraphic name. And all these kind of interesting tubes and weird shapes in here have been interpreted by geologists as bioturbation. So this would actually be muddy seafloor sediments that have then been burrowed into by organisms. If you think about the Cambrian, we still had burrowing organisms like trilobites and brachiopods, clams, things like that would actually be living in a sort of a muddy seafloor type of material. So this is actually a dolostone, this reddish attractive rock here. If we move over to the interesting green rock, this is from Vermont. This is the stone name for this is Vermont Verde Antique, but this is actually a metamorphic rock, and it's not marble. This is a metamorphic rock called serpentinite. So this rock is a metamorphic rock that forms when ocean crust gets metamorphosed, probably is injected with water, and there's some chemical reactions that take place. This rock's about 480 million years old, and this rock formed when the eastern part of the US collided with Baltica, which is the sort of Scandinavian countries today. There was a collision between those two continents that caused the compression and the heating of the rock to form this material here, this serpentinite. So not a marble, but a different metamorphic rock. Not a marble, a sedimentary rock. And then we get to this material here. This actually is a true, and I think it's the same as the gray here. I think it's just darker sections and lighter sections, but these two here are true marbles. These are from Alaska, and this is called the Tokene marble. It's actually quarried from an island in southeastern Alaska called Marble Island, so that's a great name for it. And this is, shoot, I didn't write down the age for this one, but I believe this one might be Cretaceous in age. I'll have to check on that. Definitely not as old as the other two there. So some of the rocks we see, or the stonework we see forming the floor of the Capitol building. They're doing a little work down there, but you can see some of the nice design features and such. And then the last thing we want to look at here are these immense and really attractive pillars that are formed throughout the Capitol building. And as we kind of look at these a little bit closer, we can see they've got kind of a swirly texture to them. If you're trying to identify this as a rock type, it's looking confusing. I know when I first looked at it, I was like, boy, what the heck is this stuff? Is it some sort of marble? It doesn't show the same kind of banding and forms that we might see in a folded metamorphic rock or something like that. And what this is this is actually man-made material. This is actually a plaster that's made with glue and rock dust. I think they use some ground up gypsum as well. And then they wrap this, they put this plaster on canvas and then wrap it around the columns, and then it sets up and dries. So this is a material called, it's an Italian word, I don't know if I can pronounce it right, but it's I'll spell it first and then I'll try to say it. It's Scagliola. So it's either scagliola or scaliola. And the story is that this was put together, or they commissioned an Italian family to come out here and put this material in place to form the columns and the pillars here in the Capitol building. So kind of a fun little twist where we have seemingly all this beautiful rock, and we do have some beautiful rock on the floors, but then the columns and pillars themselves are actually a man-made material. So really cool. The Capitol building is definitely worth a visit if you're interested in this sort of thing. But we'll head on to our next building now. Okay, the next building on our tour is the Idaho Dept of Lands building, right here on the corner of Bannock and 6th Street. And just across from the, I guess it's a little hard to see with the trees there, just across from the Capitol building, which is just across the way here. And this might be one of my favorite building stones in downtown Boise. This really intricate stone or rock that's used here comes from southwest Minnesota. This is actually some of the oldest rock definitely in downtown Boise on some of the buildings. It's about 3.5 billion years old. It's known as the Morton gneiss, but I believe in places it's probably better called a migmatite, which I'll explain here in a second. In the stone industry, this is known as Baltic brown. Oh, I'm sorry, not Baltic brown. It's actually rainbow granite. That's what it is. Had to check my notes there. Rainbow granite. But you can see just the swirling, intricate nature of this stuff. And what we have here, in places we have, you know, legitimately a metamorphic gneiss. We can see some of the banding here, the alternating light and dark layers, and the differentiation of those layers. Maybe like what we have kind of right through here. But then we also see places such as this little zone here, or right in here, where the texture of the rock actually resembles more of an igneous rock. So kind of it's trying to be two rocks at one time, right? It's got the foliated nature of a metamorphic rock, but then we can see in places it has the sort of phaneritic texture that we would see in an intrusive igneous rock like granite. And so what this is a migmatite, and a migmatite makes sense when you think about sort of the context of how these rocks form. So we know that gneiss is a high-grade metamorphic rock, meaning it forms at exceptionally high temperatures and pressures. And so as the temperatures and pressures increase, the minerals are segregated into these kind of light and dark bands in the foliated rock that we see here. But ultimately you can reach such high temperatures and pressures that you actually start to partially melt some of that material. And so in this case we've got the quartz and the potassium feldspar that is actually melted back into magma while the rest of the rock stays more or less solid. And so then as that magma subsequently cools and crystallizes, we get these little stringers and blebs, or even kind of zones of the granitic rock in amongst the gneiss itself. So this is really a transitional rock type, migmatite, between high-grade metamorphism and then entering back into the igneous realm of rock types. But really an exquisite rock, really attractive. Again, one of my favorites that I've seen in the area. So again, the Department of Lands building here in downtown Boise. We'll head next to our next building, which is going to be the Idaho Law Center, which used to be the Ada County Courthouse. So now we're just one block east of the state capitol, looking at the Idaho Law Center, and you can see the beige stone that makes up this building looks a lot like this similar colored stone of the state capitol. Remember, the state capitol is mostly made out of table rock sandstone, which is locally quarried for building stone. And even though this looks very similar, it's actually quite a bit different. This stone that's used in this building, it's definitely softer. They're able to cut it and shape the blocks to much more of a level surface. If you were to look over there at some of the blocks on the Capitol building, they tend to be kind of scalloped and shaped a little bit differently. We're gonna find a couple spots here, I hope, where we can see some of the characteristic features in here. This is actually one of the more popular and well known or used building stones in America. This is known as the Salem limestone or Indiana limestone. It's quarried from Indiana. Limestone, of course, is a soft sedimentary rock made out of in this case, broken up and fragmented shells and exoskeletons from different marine organisms. It's Mississippian in age. And if I kind of jump up here, 1, 2, 3, up we go. Hopefully I can get in here and find a good spot where we can see some of the fossils in here. So here's a little brachiopod fossil. You can see all these shapes in here. These are shells and shell fragments that really constitute and make up most of this rock material. Let's see, over here we have kind of the outline of probably a clam or a brachiopod shell right here. Again, all these little white chunks and speckles in here are the fragments of shells. A lot of them are more or less unrecognizable, a little hard to identify, but this one definitely, you can see sort of the fan shape here. This one is definitely a little brachiopod. So this, again, the Salem limestone, a widely used building material. Let me jump back down and see. I thought on this panel there was maybe a few more fossils. Yeah, a little bit in here. It's hard to focus there. Yeah, so a similar sort of thing. But the Idaho Law Center, one block east of the Capitol building, showing a lot of the similar, a lot of neat features in this building stone, which is used in a lot of different places. So we'll head next to our last building, which is just one block east of here, which should be the Idaho Supreme Court building. Kind of a whitish, light colored material that I think we'll find is very different than some of this other rock that we've been looking at. Okay, our final stop on our building tour of Boise buildings and the stone on their exteriors is the Idaho Supreme Court building, one block east of 2 blocks east of the Capitol, 1 block east of the Idaho Law Center we were just at. And we can see the exterior of this building is made out of panels of this white banded rock. If we get in here a little closer, we can see it has some of these openings in it. You're going to stick your fingertip in some of these. This is all calcite. This is all soft material, soft mineral. And this is a type of limestone called travertine. So travertine is typically a spring deposit. So when we have groundwater or surface water that's enriched with calcium carbonate, and that water then precipitates out the mineral material, that will form coatings of calcite, or in this case travertine, the rock type. We can see the bands run this way, so presumably they've laid all these panels on the exterior of the building, so they kind of run the same way and have the same orientation and for aesthetics, I suppose. But this would be this rock material here comes from the eastern part of the state over by Idaho Falls from the Caribou Mountains. It's a few million years old, and these are hot spring deposits. So this would be hot water moving through older limestones in the area, dissolving out some of the calcite, and then reprecipitating it at the surface to form travertine, similar to what we see today in Yellowstone National Park at Mammoth Hot Springs at the north end of the park. Some of these features in here that form these little lines that run this way could be the roots of plants that were extending into the subsurface, and then as the calcite precipitated around those roots, you sometimes get little casts that are formed from that. So I think some of the textures we're seeing here are the slow and steady precipitation of the calcite upward towards the surface at the time, and then some of these more voids in here might be plant material or just gas bubbles or air pockets within the material. So yeah, travertine. So we've seen a whole host of rock types here in an urban setting, and it's pretty remarkable that you can come to a big city like Boise and see rocks from so many different areas that you might not see otherwise. We've seen rocks from Finland, we've seen rocks from all parts of the US, we've seen igneous, sedimentary, and metamorphic rocks, all within a pretty short walking distance of each other here in downtown Boise. So hope you've enjoyed this. If you want more of a rundown on this and some of the locations, this is one of the chapters in my book, Geology Underfoot in Southern Idaho. And I hope you've enjoyed this. Appreciate it.